Good morning. Today we are going to discuss vectors and scalars. Scalar is a quantity in physics that has magnitude, but not a direction associated with it. Magnitude, which means a numerical value with units. Scalar is a physical quantity that describes the physical phenomena without any direction. An example of a scalar quantity is a speed with magnitude of 20 in a unit of meter per second. Distance is another example of a scalar quantity. Example, we have 10 meters. Another scalar quantity is age or time. So we have 15 years. Heat is also a scalar quantity in an example of 1,000 calories. On the other hand, vectors or a vector quantity is a quantity in physics or a fundamental quantity that has, or a physical quantity that has both magnitude and direction. Let's take note that we write vectors with an arrow on top. So if we have a symbol, for example, for velocity, a magnitude of 20 meters per second in a given direction moving to the north. Writing the symbol for velocity will be v, a small letter v, with an arrow on top. For acceleration, so we have vector acceleration. An example of this is 10 meters per second squared moving to the east. For the force, we have 5 newtons west. Now let's take note that vector quantities can be represented by an arrow. We are going to draw a vector. We will draw it using an arrow. The tail of an arrow represents the origin of the vector. The head of the arrow or the arrowhead represents the direction where the arrow or the vector is moving to, while the body of the arrow represents the magnitude, how big or small the value of the vector. Let's try to add vectors. If two similar vectors point in the same direction, then we add them. Example, a man walks 54.5 meters east, and then another 30 meters east. We calculate his displacement relative to where he started. So we have the first vector, the blue represented with this blue arrow with 54.5 meters east. And then the man walks another 30 meters east, which is represented by this red arrow. So adding this, the total displacement of the man is just equal to 84.5 meters with the direction moving towards the east. Let us notice that the size of the arrow conveys magnitude and the way it was drawn conveys the direction. If two vectors are going in opposite directions, you subtract. Example, a man walks 54.5 meters east and then moves 30 meters west. We calculate now the displacement relative to where he started. So the arrow moving to the east is represented by the blue with 54.5 meters east. Then he returned 30 meters west. So where he stopped. So that's the displacement. So we subtract 54.5 meters east to 30 meters west. Sorry. We subtract 30 meters west to 54.5 meters east. Therefore, our answer is represented by the small arrow in violet at 24.5 meters east. When two vectors are perpendicular, we must use the Pythagorean theorem. Example, a man walks 95 kilometers east, then 55 kilometers north. Then we calculate the resultant displacement. The first vector, the 95 kilometers east, and the second vector is moving towards the north with 55 kilometers. So this is the point where he started, and this is the point where he stops walking. We need to calculate the resultant displacement. This dotted arrow represents our resultant displacement or our resultant vector. Let's take note that this conveys us or formed us a right triangle, which means that we can able to identify the resultant displacement using the hypotenuse. Let's take note that this hypotenuse in physics is called as the resultant, either resultant displacement as a vector quantity. The legs of the triangle is now called as the components. So we have the horizontal component and the vertical component. So to calculate this, we need to use Pythagorean theorem. So we have c squared is equal to a squared plus b squared, which can be transformed into c is equal to the square root of the sum of a squared and b squared. So c now, as our hypotenuse, is our resultant, which is now equal to 95 squared plus 55 squared, then we get the square root of the sum, which is 109.8 kilometers. In this previous example, the displacement was asked for, and since it's a vector, we need to identify the direction. Let's take note. When drawing a right triangle that conveys some type of motion, we must draw it through the head to tail. Drawing vectors is using the head to tail method. The first arrow or the first vector will be drawn, and the second arrow will be drawn on the head, or the tail of the second will be drawn at the head of the first vector. So it's the head to tail method. Let's take note of this directional guide. If the angle between the triangle is at 45 degrees, then it is called as northeast or southeast or southwest or northwest. But if the angle is lesser, depending on the relative to your angle, then we may call this, in this example, as north of east or east of north. We may call it also as southwest, west of south, north of west, west of north, south of east, and east of south. Let's take note that when naming the angle, we need to look into where is our relative angle, where it is placed, and where are we going to look. So here, our relative angle is between north and east. So we are going to call it northeast. So to find the value of the angle, we are not able to have the exact uh, value yet, but to identify this, we need to use the angle using the trigonometric function tangent. So here, to identify this angle, we are going to use tangent theta is equal to the opposite side divided by the adjacent side. So we have 55 divided by 95, which is equal to 0.5789. Furthermore, just to get the angle, we need to operate tangent into the other side. So we need to have tangent arc, tangent -1 or arc tangent multiplied to 0.5789, which is equal to 30 degrees. So to complete our answer in this example, it will be 109.8 kilometers, 30 degrees north of east. Another example. Suppose a person walked 65 meters, 25 degrees east of north. What were his horizontal and vertical components? So the goal here is always make a right triangle. So to solve for components, we often use the trigonometric functions sine and cosine. So we have here 65 degrees, 65 meters, 25 degrees east of north. So our angle here is lies on the y-axis. So here is our vertical component, which is missing. Here we have the horizontal component, which is also missing. So to solve for the components, we will still use cosine and sine functions. So here, the adjacent side, since this is our relative angle, our adjacent side becomes the the vertical component, while our opposite side is our horizontal component. So to identify this, we use this equation. The adjacent side is equal to the hypotenuse multiplied to cosine theta. So to identify the vertical component, which is the adjacent side, we multiply 65 cosine 25. Then we get 58.91 meters north. So to get the opposite side or the horizontal component, we multiply 65, the hypotenuse, sine, and then 25, which gives us 27.47 meters east. Another example, a bear searching for for food wanders 35 meters east, then 20 meters north. Frustrated, he wanders another 12 meters west, then 6 meters south. Calculate the bear's displacement. So the first vector is 35 meters east, while the second vector is 20 meters north. Then another vector, vector C, is 12 meters west. And then another vector is 6 meters south. So here, we need to add first all the horizontal components. So we have 35 minus 12 is equal 23 meters east. Then now, we add all vectors lying on the vertical axis. So we have 20 meters north minus 6 meters south. Then we have 14 meters north. So to make a triangle, we have 23 meters east and 14 meters north. Here we can use the Pythagorean theory. So to identify the total or the resultant displacement of the bear, we need to use this equation. We have 14 squared plus 23 squared, then get the square root of the sum. And we will arrive with 26.93 meters. To identify that the angle, we need to use tangent theta is equal to 14 divided by 23, which is equal now to 0.6087. So to identify the angle, we use tangent -1, 0.6087, which is equal to 31.3 degrees. So the final answer will be 26.93 meters, 31.3 degrees north of east. Another example, a boat moves with a velocity of 15 meters north in a river which flows with a velocity of 8 meters west. Calculate the boat's resultant velocity to with respect to due north. So here, the boat moves 15 meters per second north. So that's his velocity. So that's the velocity of the boat. Then it was moved 8. It was moved by the current of the river by 8 meters per second moving to the west. So what is now the resultant velocity of the boat? Based from our drawing, we can use the Pythagorean theorem. Looking into these answers, the final answer now is 17.0 meters per second at 28.1 degrees west of north. Let's take note that the relative angle is placed along the y-axis. That's why it is named as west of north and not north of west. Another example, a plane moves with a velocity of 63.5 meters at 32 degrees south of east. Calculate the plane's horizontal and vertical velocity components. Let's draw. So we have at 32 degrees south of east. Let's take note that the angle is relative to the x-axis. So this is south of east. So it is at 63.5 meters per second. So we need to identify the horizontal and the vertical components. So using the cosine and sine functions that we have used a while ago, and we can come up with the following answers. For our last example, a storm system moves 5,000 kilometers due east, then shifts course at 40 degrees northeast or 1,500 kilometers. Calculate the storm's resultant displacement. So here, we look into first the horizontal component of our vector. So we came up with 6,149.1 kilometers as the horizontal component. Here, you can identify the total resultant displacement by using Pythagorean theorem, where we use the vertical component that we calculated here. So the final answer now is 6,224.14 kilometers at 8.91 degrees north of east. Thank you for listening. I hope you learned something from vectors and scalars.